So our final speakers,
They're BSides champs.
yeah, actually, inaugural and world champion. We should really have some like WWE music, like you guys rolling in. Give me some John Cena. These fine gentlemen are here to talk about things, specifically tools that they've built. So Mike, Chris, and Andrew are all senior cybersecurity researchers at GE, and so thank you guys or your organization for sponsoring. And again, they're here to present on a tool that they have built. And so last talk of the night, and we're excited to have them. So take it away, guys.
Thank you. Check. This thing working? Maybe? No? Yes, we hear you good. All right. Hey guys, so the presentation that we're going to give today is one that we've titled Automating the Hunt, and it's about endpoint hunting and different methods that we've come up with on our research team over the past couple of years. Specifically, we're going to talk about two different tools that we've developed called Hashbrowns and BAGELS. I'm going to go ahead and get the legal disclaimer out of the way real quick. Hashbrowns and BAGELS are copyright or something like that. And these are tools that we have developed through our company, GE. We'd like to open source them and get this out to the public, but at this time, unfortunately, we can't really share source code. So I'm just going to kind of break that news right off the bat. What we are going to do is we are going to talk about the techniques, and we're going to give some snippets and that sort of thing. And really the whole motivation behind this presentation is to get folks thinking about how can we do things better? How can we look for bad things, and how can we help ourselves by automating those processes and do that better? Unfortunately, that means unfortunately we just can't give source code today. Okay, so who are we? We are these three fine-looking gentlemen up here. My name is Mike. You can probably recognize me because I have the best haircut. As mentioned in our quick introduction, we all work for GE Power, about to be GE Digital Power, and we're cybersecurity researchers. So we kind of look at the hard problems and try to come up with tools in different ways that we can do security better. I'll let the other guys introduce themselves.
Yeah. Yeah, I'm Andrew. I'm a colleague of Mike's on the GE Power team, more Intel focused than advanced malware analysis. These guys, I'll admit that for this project, these two were the most of the coders. I just kind of gave them input and helped develop Intel, but these guys did most of the heavy lifting, so got to give credit where it's due.
And I'm Chris Boettcher. I've been on the team for a couple years now. Prior to that, I did security patching and stuff for GE, so I've been in a semi-security space for a while, but just excited to be here.
Sweet. So we won't belabor that for too long. All right, so what are we going to talk about today? What is our roadmap? Looks something like this. So we're going to talk about a little bit of basic stuff. I'm sure that a lot of folks in here are going to be familiar with some of the concepts that we're going to talk about in the Back to Basics section, but I wanted to go ahead and conclude that section just to put everybody on a level playing field. Second thing we're going to talk about is we're going to talk about hunting for static IOCs. Now talk about really what that means to us and how we've done it in the past. And that's going to segue into how can we do that better? How can we hunt for static IOCs in the enterprise environment better? Well, we don't just want to look at static IOCs, as several of the other presenters have talked about today. There's a whole different group of indicators that we can look at called behaviors, which is essentially looking for ways that your system might be doing things maliciously by looking at the behaviors in the system. And then we're going to talk about how can we do that better? How can we automate that process? All right, back to the basics. I want to start with, what is threat hunting? I think that if you ask 10 different security researchers, 10 different security professionals, not just researchers, what do they think, threat hunting means? You're probably going to get about 7 different answers. Maybe even, more than 10, actually. I don't know. But I kind of like the Wikipedia definition, not because it's super easy, I can just copy and paste, but because it's broad, and it kind of just gives us a basis to go from. The process of proactively and iteratively searching through a network to detect and isolate advanced threats that evade existing security solutions. That's kind of a generic definition, and that's kind of why I like it, because you can kind of adapt that for whatever you mean. But really, it means hunting for bad things. It means finding the things that are wrong. It's the whole assumed breach mentality and then go out there and find it. You have to think like an attacker, and you think, what would an attacker do? What kind of post-exploitation things would they do? And then go out there and try to find it within your network. How you accomplish that, there's a whole bunch of different ways to accomplish that. And we're going to talk about just two different tools that we've thought of over the past year or so. This presentation is going to be focused on intelligent-driven methods, and I'm going to talk a little bit more about what that means in upcoming slides for hunting on the input. This is going to be in contrast to other approaches that are more like behavior analytics or anomaly detection. So intelligence-driven means that you have information about the bad guys. You have information about what they're doing, whether you gather that information from your own intel program, whether you get an intel feed from somebody else, or whether you get that from partners or something like that. And all of these are very valid methods of approaching it. Anomaly detection and behavior analytics, those are awesome things to be doing, and we absolutely should be doing all of these things. And that's going to be kind of one of the themes that I want to talk about and kind of harp on today, is that there is not one size fits all, one approach. I'm going to install this tool that does user behavior analytics, and that vendor told me it was better than looking for static IOCs, and therefore their pitch was the best, so that's what we should go with. No, my theme and my message is that we have gotten to the point where we can automate these things and we can do all of them. We don't have to choose one method over another method. We need to choose the best portions of each method, combine them together to an integrated strategy that works across your enterprise. So what is an indicator of compromise? I'm not going to spend a whole lot of time on this slide because I think a lot of folks here probably do know what these things are. I decided to splash up here the Pyramid of Pain, which was developed by David Bianca, who is a GE alumni. And what this does, it kind of talks about different indicators that we could be looking for. Starting down at the bottom, IP addresses. I think he actually added another layer below this, which was hashes. But then you got things like IP addresses, domain names, network artifacts, host artifacts. And then as you start to get to the top of the Pyramid of Pain, you start talking about a little bit more abstract concepts like tools and TTPs, or tools, tactics, and procedures, actual methodologies. And I think this is just a good thing to look at because it shows the different things that we can turn into indicators and the different ways that we can approach detection and hunting. So where do indicators come from? Well, in our case, they come from intel. And like I mentioned before, intel is where you know something about what the bad guys are doing. There's a whole bunch of different ways that you can get that. You can get that from threat feeds, which you pay for. Some of those are limited. Some of those are better than others. You can get those from, and a threat feed might just give you a whole bunch of domain names. And maybe if you don't know how to use those in your enterprise, they might be completely useless. So if you're looking at different threat feeds, think about where you are in your maturity level and what tools they're going to go in and that sort of thing. You can also be part of an information sharing group, such as government information sharing group, like DSIE is defense-based, where a bunch of analysts get together on a forum and they talk about attacks they've seen. They share YARA rules. They share different phishing campaigns, that sort of thing. There's industry-based ones. ISAC, we're part of the energy ISAC. The financial ISAC is one of the most mature ones. There's also open source threat intel. The font color there is not showing up the best, but that's a link to a GitHub called Awesome Threat Intel, which just has a ton of resources. If you guys have never been to that, I'm not sure who the guy that maintains that is, but whoever it is, serious kudos to them, because that is a great source of open source intel feed. And then I posed the question, are IOCs dead? And I believe I actually have another slide. Nope, don't. Are IOCs dead? This is kind of a religious debate to some information security professionals. You talk to some companies, and they say, yeah, we don't care about IOCs anymore because, static bytes just aren't going to cut it because you can change, you can tweak something. Well, and all these things go out the window. Well, sometimes yes, sometimes no. Like I said before, I don't agree with the mentality of, okay, well, this approach, be it, user behavior analytics or anomaly detection or something like that, is going to be the end-all, be-all. I mean, I think that we have to take each approach and look at the tools and what they actually provide and integrate them together. I don't think IOCs are dead, and I'm going to talk a little bit more in 2 slides on why that is. And it's a transition slide. Maybe it's inappropriately placed. I don't know. Hunting for static IOCs. So I'm going to come back to that question of why are IOCs dead on the next slide when I talk about what's working in enterprise and what's not. But first I want to introduce a tool that we use called Yara. Show of hands, how many people know what Yara is and use it on a daily basis? All right, some. Okay, cool. So Yara is the pattern matching Swiss knife for malware researchers. It's kind of like grep on steroids. It's a very easy way of describing it, but it really is a lot more powerful than something like grep. It basically allows you to create your own, for a lack of a better word, I know somebody's going to kill me, like AV signatures or something along those lines. Basically what you're looking for is you're looking for byte patterns. And it's super flexible. It allows you to put in variable number of bytes. It allows you to put in all kinds of different wildcards. It allows you to, with using their modules, it allows you to look in certain sections. It's very smart. It knows what kind of files you're looking at. So with some of the later updates in it, you can look in different sections of like PE headers and that kind of thing. And what this does is it allows you to create static signatures that are very valid for different malware families and various tools, not just malware, but other tools and other files that are a little bit more robust in the sense that if they tweak something, it's not they tweak something that's going to change a hash, or they tweak something that's going to change a domain name. It doesn't completely invalidate your signature if it's written correctly. I mean, obviously you got to have well written and well quality tested rules. You can't just okay, well, if it contains all these strings, then it's going to be a good rule. I mean, you got to think about it. You got to have, real reverse engineering. You got to look at, byte patterns. I mean, you can look at things like, the way that they might push bytes onto a stack to create strings. So a lot of malware likes to obfuscate itself. And so when you run strings on it, there are no strings. It's all completely obfuscated. But there might be a routine in there that pushes 4 bytes onto the stack and pops them in a certain order, and then all of a sudden, the way that it does that, it creates a string. Well, you can look for those instructions. You can look for those push instructions. You can look for those pop instructions. You're not actually looking for string values. You're looking for specific assembly code instructions. And so that's the level that Yara gives you. It gives you the ability to go in and actually look at that kind of thing. So that's the primary tool that we use to hunt for what I would call static IOCs. And for lack of a better definition, we're talking about file contents, malicious files. Whether they be artifacts dropped by malware, malware themselves, that sort of thing. You can also look at IOCs inside a memory, memory-only IOCs. You can also use it across the network with frameworks such as you can integrate it into frameworks like Bro. You can integrate it into like a boss, those sort of frameworks. You can use this as well. So you can use it on the network. You can use it on the host. The project that we've been dealing with is primarily on the host. I'm running way late, aren't I? I got like 2 minutes. All right. So let's talk about the challenges. Let's talk about first the good things that we've been able to do historically, and let's talk about some of the challenges that we've faced to really provide motivation for what we're working on here. So how has static hunting been working well within the environment? Intel sources are really good. I mean, we've had a very good communities build up over this. Like I said, I mentioned the various ISACs. I've mentioned the various government organizations. There's some semi-private groups out there. Yara Exchange is what I would consider a semi-private group. It's like, it's technically restricted, but I think if you just send the curator an email and just tell her who you work for, she lets you in. So there's great communities out there, and what that means is basically when a new phishing campaign comes out, a company gets hit, a company gets popped, they hop on these forums, they write these signatures, and then you get that information pretty much right away because of that robust infrastructure that's already set in there. I can't really say the same around some of the newer technologies, some of the things like behavior analytics and anomaly detections. You don't really see a lot of folks popping up and saying, okay, well, this is how I set up my machine learning baselining for this network tool. It's a little bit more vendors heavy at that point. So as far as these static IOCs and using Yara, I mean, we've been doing really good in the whole like Intel sharing world. High fidelity. With proper QA and proper testing, the rules that you create using Yara and various very simple scanners are very good. You get a hit on that, it's probably going to be malicious as long as you wrote the rule. You can always write crap rules, and people do write crap rules, which is why we have Andrew over here working on QA code for us, which he's published. He actually has a DerbyCon presentation on it. It's out there in the open for folks who are interested in that. It's a different presentation. You can get it Email scanning. Email scanning is great. You get emails in all the time. You can quickly run it through some Yara scans. You run it through a whole bunch of rules. You know if there's a malicious attachment, or you know that you have malicious code potentially present in those attachments pretty much instantly. And one thing that I want to kind of mention, kind of backtrack for a second, why do we even have this as opposed to AV, just using AV? Doesn't AV do the same thing? Well, yes, to a certain extent, but the thing here is that we can leverage these Intel sources to create custom signatures for things that are bleeding edge, late breaking, that sort of thing, which you can't do, which you can't necessarily do with an AV vendor. You can't call an AV vendor up and say, I need a signature deployed now. So that's the difference. They do sometimes have helplines and submissions and that sort of thing, but in more robust programs, you want the ability to create custom signatures, and that's kind of the whole reason why we do this to begin with. Post-mortem analysis. So something goes wrong, something goes bad, you have a whole bunch of files on a system, you believe that some of them are malicious, why not just scan them all? And it works pretty effectively. So what's not working, or what has been an issue? I'm not going to say this hasn't completely worked, but what have been issues? Full system scanning. The rule sets get super big, and if you don't have a very tight Intel program that's constantly weeding out bad rules, that sort of thing, to do a full system scan across 100,000 endpoints has turned into a nightmare. I mean, that's something that we've struggled with for a long time. It's hard. It's just hard to do it. It's very resource intensive. You have to throttle it back, because if you run these things full on, if you run 1,000 rules through 500,000 files on an in-system computer, you're going to turn that thing into a space heater. And users tend to not like space heaters. They don't like their fans going up to 1,000 CPU. I mean, that's one thing that I always thought was crazy. You get these folks that have no background in IT at all, but they definitely know how to open up the task manager and tell you which process is running at 90% CPU. And they kill it. Anyways. No matter what it is, they'll just kill it. And then they'll send you an email being like, why is this running? So just getting these things accomplished. I mean, you have to restrict the CPU utilization. I meant to pull the numbers, but I didn't, because I guess I'm lazy. But we did this when we were doing this. Just running basically all of our rules through the entire system. It would take a week to complete. We'll say a week to complete on some of these systems. 20 hours plus to complete. Real-time scanning. Real-time scanning is something that's hard to do with just Yara by itself, right? I mean, you can't. As soon as a file is created, it might be another week before you get another full scan. And we know nowadays that artifacts don't generally last on a system for that long. Artifacts are usually pretty ephemeral. So what if we could stop scanning the same files over and over and over again? Because that's pretty much the approach we have. You have your giant rule list, you have your giant file list. We just scan all the files with all the rules, and we do it once a week. And then once you think about it, that's a lot of duplication, because you're scanning the same files over and over and over again, week after week after week. And not only that, but if you ever look at 100,000 endpoints, 90% of the files are the same, because most of them are operating system files, and they're completely legit, and you don't need to scan them to begin with. And also, what if we could scan files in near real time? So those are the two things that we're looking for when we developed Hashbrowns. So the whole idea behind Hashbrowns is we're gonna do distributed scanning. So instead of just scanning one computer with the entire rule set, we're gonna break that rule set up and scan all the different files, no matter where they're located in the entire network, just one time. We're gonna use dynamic rule sets, so that only the rules that need to get deployed to a particular file are gonna get deployed. So like if a new rule gets created and a new file comes along, and maybe this file has been seen before in the past, and we scanned it with half of the rules, this time we're only going to scan it with the other half of the rules. So this is a dynamic rule set. And there's a couple different ways that we're going to accomplish that. We're going to accomplish that by first taking a full system inventory. And what that means is we're basically going to collect information on all the files in the system. And so that way we know what all the systems have. After we get done with that, we only have to take partial inventories. We only have to take inventory of the files located on the system that have been created since the last time we've done the initial inventory. And how are we going to accomplish all this? Where are we going to store this data? Well, the cloud. Duh. It's 2017, man. We're going to put it in the cloud or something like that. So, I mean, seriously, though, I mean, we live in a great time. What I'm proposing here essentially is taking a full system inventory, hashing all of your files. That's metadata. We're not actually taking content, and we're taking locations of where all those hashes are located, and we're going to ship them up to a centralized location or a distributed cluster of things, a data lake. I don't know. Some data scientists can figure this out. They tell me that this stuff scales. But we live in a great time where that actually is a thing. It's actually a real thing that we can do this. We can store that amount of information. By the way, your average computer has somewhere between 200,000 and 500,000 files on it, roughly, somewhere in that range. If you're outside of that range, I don't know. Anyways, that's rough. That's roughly the range that these things are in. So storing that information up in the cloud allows us to track where these files are, and allows us to scan them with only the rules we need to do it. There's some awesome benefits from that, which I'll get to sure now. The benefits to that is that by the time that you get to by the time that you finish the full inventory and you're only dealing with partial inventories, you're only dealing with, instead of dealing with 500,000 files, you're only dealing with a couple hundred files every time you do that check. And to scan a couple hundred files only takes like a second or two. And so what you can get at is you can reduce the loop of how often you scan to where you can catch newly created files. I don't recommend scanning every single file on access, because then you're talking about like hooking kernel drivers and that kind of stuff. And obviously there are products out there that do that. But you know, if you're not trying to get into kernel land, which I tried to stay out of kernel land because I don't like to hook the kernel and break things. What you can do is you can get that loop down to just every couple seconds, check to see what new files have created, request a new rule set from the server, and scan those, and it gets super quick. So instead of waiting an entire week to determine if a new file has popped up on your system that's malicious, you can get that pretty much in near real time. So let's talk about how this process actually goes. I'm going to have to blaze through this. Yep, no one can read that, right? I can't read that. I'm standing right next to it. Sweet. We don't have time for this anyway, so we don't have time for this anyway, so I'm just going to say what this is. So basically, the first part of it is you have to take an inventory. There's a couple different ways that we take the inventory. We take the inventory just by running through the entire system, looking at all the different files on the system, taking a hash of them, and then shipping those back up to the cloud and saying, here they are. Next way that we take an inventory, a partial inventory, is we say, hey, server says, hey client, last time you gave me an inventory was this date. Tell me all the files that have been modified since then. Then the client will go check all the files on the thing, on the system. We're talking about agents that are running on your client here. It checks those. Then it sends back only the ones that have been modified since that date that it gave it. The third way is we actually use sysmon, and Chris and Andrew are going to talk to you a little bit more about some of the cool things that you do with sysmon. Sysmon, you can actually create a listener that listens for when new files are created and then queues them up. So that way you don't even have to talk to the controller. And there's a couple different configurations here. So you can control how often it does a check-in with the controller. You can control what information is actually stored on the machine. And you can control how big of the queue, how often you want to check that queue for new files that sysmon is basically dumping into the queue. So a lesson learned here is the first time that we did this, we wrote it in C#, and we used the Windows APIs to go all the way through this. Using the Windows APIs to do the whole directory traversal and the whole trying to find the creation dates. We ran into a big problem. Can anybody guess what that problem would be by using Windows APIs to go through the directories and find out where all the files are at? Huge problem. And that is AV, man, hates that. And the reason why AV hates that is because anytime that you have an open handle using the Windows APIs, AV is going to scan it for you. So we determined that when we were doing this, everything was getting scanned all the time by like Windows Defender and HIPS. Like literally every single file in your entire system, it just like totally destroyed it. So don't do that. You're either going to have to whitelist your process so that your AV doesn't do that if you're going to use this in like a higher level programming language like C# or something, or you can just get really familiar with the master file table and learn how to use raw access and traverse the master file table for this, which is the way that we're going to go now. We're actually in the process of writing that code. PowerShell Empire actually has a library to help out with that, in case anybody's interested in learning how to access raw volumes, read the master file table, then go through them to find out where things are located. This is another chart that nobody can read, and essentially what this is talking about is how scans are created once the client client checks back and says, hey, give me a new scan. And there's a process which is here. But essentially what the process is it says, okay, which files have changed since the last time that you checked in? What rules have they been scanned in? There's a collection of databases. It looks at those databases and it says, okay, these files need this rule, these files need that rule. We do some averages because files might be all over the place. So we say, okay, what is the mode? What is the most common date that these things were last scanned, or what is the most common rule that they were scanned with? Anything above that, sent to this group of files. Anything below that, sent to this other group of files. So we have a couple different database tables that we set up here. We have this one called the file hash table. This is where we just store all the hashes across the entire enterprise. So your client checks in, and it checks in with this information. It provides your SHA-256 because that's the best SHA. It provides the last rule that particular hash was scanned with. It provides the last time the status was updated and the first time it was seen. But really, the only two important things up there are the hash and the last rule that it was scanned with. And then we have the file table. So this is a totally separate table. And again, these things are going to be storing a lot of data. So distribute that or something. So the file trackers are actually storing the locations of the files. And these things are linked with a foreign key to where the hash is actually. And so in this case, we have a UUID for each file, which is just dynamically generated. There's some code there at the bottom. This is a Django model here. The client that it was found on, because each tracker is specific to the client. The file hash, which is a foreign key to that previous model, the actual hash of that, because the idea there is that the same files are located on multiple computers, so multiple files will have the same hashes. And the file path, which is just a text field so you can actually find it. And the last thing here is we actually have the alert model. So once there is an alert, you just basically link it back to the file hash, and the file hash, through the magic of foreign keys, the trackers can link back to the file hashes. So every time there's alert, it has this beautiful byproduct of whenever you get an alert on a file, you actually know exactly across your entire enterprise what other machines on your enterprise contain that same file, because you have a foreign key link from the file trackers to that hash, which now has an alert also associated with it. So if you identify a hash as being malicious, you can know, if you have 100,000 machines, that same attachment was downloaded by 6 other users in 5 different countries, which is really cool if you have a big organization like ours. I mean, this is a pretty big feature for us. So if folks are interested in this again, I know that a lot of the details we really couldn't drill down to. That some of it's because of timing of this presentation. Some of it's because we're not able to give out source code right now. So what I really just wanted to try to drive home is that we can do things automated. We can hunt for rules. We can distribute these searches across the enterprise, leveraging a centralized controller, leveraging the cloud, leveraging distributed services that we might not have been able to do a couple years ago. And if folks are interested in learning more, I please encourage everybody to come talk to me about it, and we can get into more details. Just real quick, a couple lessons learned. Speed increase. So before we were seeing alerts that were getting hit maybe a week at a time. That was assuming that the scan's actually completed. Now we can see a malicious file getting detected. When we did it in the Granite environment, and things showed up in a minute after it was created, and that's not even the final form, and we're still developing our own stuff internal. Time to detection, like I said, we can see things within a minute. Enterprise's awareness of threats, that's where you find one hash that's malicious, you know exactly the computers that it's located on. Lesson learned is that you need to use raw volume access, because if you don't, you're going to run into issues with AVs. Storing rules locally, that's another thing that we've there's a whole bunch of different ways to do that. If you're interested, please come talk to me. And scanning newly created files autonomously. And what that means is whenever a new file is created, you know that more than likely it's going to need to get the whole rule set. So if you're storing the rules locally, just go ahead and scan them right off the bat, and then report back to the controller later. That helps reduce some network traffic, that sort of thing. So this is Hashbrowns has basically been an approach to take something that's been around forever, been around for decades. Simple scanning for byte patterns, and kind of modernizing it. It's not dead. IOC hunting is absolutely not dead. It's quick, it's effective. We just need to, come up with ways to do it better. It's not the only way of doing things. In fact, there's a whole bunch of presentations and a huge emphasis, I think, in the community right now to do behavior analytics, which is in stark contrast to, static. So that's kind of what the second part of this presentation is. So how do we go from hunting for something that's just bite patterns to how do we actually start hunting for behaviors, things that your system is doing that it's not supposed to be doing, post-exploitation. So the bad guys are in your system, now they're going to be doing some stuff. So I'm going to turn it over to Andrew, and he's going to give you a bunch of memes.
Yeah, thanks, Mike. Yeah, I'm kind of the comedic relief. My slides have a lot more funny jokes in them than Mike's.
Thanks.
Yeah, but so I'll let you decide on that, Justin. You can tell me later. So like Mike said, I'm very familiar with Yara. I used it for a long time, and kind of helped determine what the next iteration of us using it locally would be. But ultimately, I recognize that we needed to do more than just bite pattern matching. Carbon black, like Sean mentioned this morning, I really dug his talk. Carbon black in Falcon Host, and the new guy in town. What's the open source project? What's it called? I'm blanking on it. But it's basically endpoint detection, and we wanted that capability. I have a lot of indicators when I read a malware write-up or I produce my own malware write-up. I have more than just a Yara rule when I come up with it. I have all types of behavioral things that malware did on the host, and honestly, I want to be able to detect on them. And the tools that I had at the time were not really cutting it. So our team kind of as a whole came together and said, if we wanted to develop an agent like Carbon Black, Falcon Host, or something of the sort, what kind of stuff would we actually want to monitor for on the endpoint? And that kind of was how we framed this whole subject. Is first off, we had to define what is it that we actually want to look for. And so if you ask a security guy what he wants to look for, it's all the things. I don't really want to be limited. I basically want as much access as you can get. I like more data. The more data I have, I can funnel down what I'm looking for. But if I don't have the data to begin with, I can't open it up. So essentially, if you ask me what I want to see, I want everything. So we're going to go ahead and start. First, I want process traces. I want parent IDs and child IDs of all processes ran on the computer. This is like the bread and butter of Carbon Black or Falcon Host, if any of you guys have used their tool. Being able being able to view what processes start what other processes up and down the stack. Network data. Ultimately, I want source. If nothing else, I want source and IP, destination, and host names locally. I don't want to depend on a network sensor and my packet crossing that sensor to tell me where that packet is going. It's much easier for me just to get that data from the freaking endpoint, right? Why do I have to even bother with it passing a sensor in the first place? It's one more thing I have to worry about. Obviously, I want file system data. I want files created, times, all locations, all types of stuff. That's typical. Timestamps. That's also, I don't even really need to mention that, but that becomes really important later on for something else. I want registry data. Registry is kind of its own weird little thing in Windows. It's Hive data. It's not really on disk. It's kind of goofy. So I wanted to be able to monitor what kind of changes are made to the registry on the endpoint. And this is one thing that I've always wanted that always kind of really upset me is that I just want command line history. Why can't Windows give me an easy way to monitor what is typed at the command line? I don't really want to have to write a giant tool to figure this out. It honestly should have been a feature from a long time ago, but it's still not in there. They're working on it. Honestly, if you have the newest version of PowerShell, you can enable PowerShell logging and command line logging, but it wasn't there for the longest time. And that was one of my dream things. As an analyst, I want command line history of endpoints. And then ultimately, I want processor memory. Our tool doesn't do that. Not a lot of people will let me muck around in live processor memory, and probably with reason. I don't really feel confident enough to actually do that yet, and that's me. I'm Sad Panda. I can't. Nobody will give me access to process memory yet. Tools are kind of out there, and they're getting that way, and hopefully it'll be like that in the future. But it's one of our long-term goals, but not at the time right now. So we finally have our own agent. What exactly are we going to do with it? We should start mucking about in kernel land. And like Mike said, we're not going to do that. We don't really have the time or the resources or the experience to create a production level kernel monitoring driver. We don't really want the responsibility for taking down large swaths of someone's production network and getting fired. So we decided to just basically stay out of kernel land. And really, if we had to, we would have gone here. But when we started this project, we were like, you want to go in kernel land? And Mike's like, no, not really. And Boettcher's like, I don't know, too much either. And we were like, well, what are our other options? If we don't have to go into kernel land, let's not go into kernel land. And so the beauty is that we don't have to. Microsoft is actually getting really good at allowing us to gather all this information about the system in a very structured and supported method. And the first being WMI. A lot of people hear about WMI. I have in the past. A lot of system admins use it for a long time. But WMI basically allows a way for you to query information about a system. Practically anything. It has its own language. It's a Windows query language. Looks a lot like SQL, but basically you can write out complex commands asking the system information about itself. You can create event subscriptions. It's highly supported, which is another big thing of ours. We don't have to reinvent the wheel. There's tons of documentation. Like, I don't even know. It would take someone 10,000 years to read all the documentation out there. And then we have event subscriptions, which is a way to basically not for us to continually query the system, but basically telling the system, hey, I'm going to set up this query. You continually ask Windows this query, and then if the data comes back that I'm looking for, let me know about it. And honestly, it looks a lot like a signature. I can ask the system for, I'm telling the system I'm looking for this certain type of data, and if it comes back, let me know about it. So it actually looks a lot like a signature in a lot of ways. The way to write them can be really cryptic, and honestly, the Windows development documentation, you can get lost in there. You know, I have, where you're 10 tabs deep and you don't even know where you started, and you just have to close the whole browser and start again because you don't even know how you got there in the first place. But the beauty is that we can also chain them together. So the first one is how you actually monitor for a process being created. And then the second one is basically a query based off that one. So you get the results back from the first query, and then you use the parent processor ID from that data to query the information about the parent process ID that created that process. So you can move forward and back and chain inputs and outputs from WMI. And that's not new. We're just kind of using it, as a way to look for security event data. And then the other way is Windows event logs. Windows event logs are becoming, they're old, reliable. They've been around forever, and Windows just keeps putting more and more features into them. In a lot of ways, for the advanced stuff that we want to do, we really needed to get into the Windows event logs. A lot of the Windows security audit logs that aren't turned on by default, if you wanted to detect on really crazy log anomalies or login anomalies, you needed to enable those things and then look for certain event codes in those logs that you've turned on. So we really needed to get in Windows event logs one way or another. And then ultimately, if we have any tool, if any of our plugins on the system can write to the Windows event logs, then we can use them as part of our tool, which is also kind of one of the nice things for us. I said we didn't create a kernel level driver, and that's because someone made one for us. Does anybody know who this is? See, yeah, some people know who this is. He's dreamy. Yeah, this is from his LinkedIn webpage. I wanted a picture of him, and I was looking. I was like, dang, he's a pretty good-looking guy. But that's Mark Rasinovich, and I gotta give him thanks because without him, our project wouldn't have really came where it was. And mainly Sysmon. I don't know if you guys have checked Sysmon lately, but it's real old school. Sysmon's been around forever as part of the sysinternal suite that Mark Rasinovich, created on his own because Windows wouldn't do it themselves, and then he sold it to Microsoft for like $1 gajillion. It's supported by Microsoft. It's a kernel level driver. And the update, this was actually one of the key things about the update, is the update made it so that for one, it provided documentation. The documentation for it was not very well done before, and creating a sysmon config was kind of like, good luck, buddy. Here you go. So now they got a lot of detailed documentation, and also the config file is essentially a pre-filter. So sysmon will monitor all these different events. You got 18 different events, and before there was only about 10. They added about 8 different ones in the last update, which increased visibility on a major way. But also the config file allows you to pre-filter. So all these different registry events, you don't actually have to look for every single registry event. I don't know if anyone's ever done that, but the Windows registry is actually really, really busy all the time. So you can basically pre-filter these to only look for certain registry hives that you're interested in. So essentially our scanner that parses all this data, the data that it has to parse is already limited by what we're looking for in the first place. This is a nice free config to start with. I would definitely recommend using this. It's 400 lines already, I think. And it gives you a nice starting point for lowering the amount of data that sysmon is going to produce for you in the first place. And the beauty about sysmon in this kernel level driver is that it gives us access to a lot of the things that we determined we wanted access to in the first place. Like event ID 1 is process creates, so that'll give us process trace data on a kernel level. File create times is if you ever want to detect on time stomping where a file create times are changed over lots of files in a very short period of time. It's not usually normal. Network connections will give us source and dest IP and host name, kernel level. File creates gives us access to the file system. Registry gives us access to the registry. This is what a sysmon event type 1 actually looks like, and you can see tons of data. This gives us tons of data, almost too much for us to go off of. We got users, we got the process ID, the parent process ID, the GUID that you had, your user ID and level of security level that you had when you ran it. And does anybody notice the bad stuff in here? It's pretty obvious. I don't even know if I think I highlighted it. But you also get command line history is one of the things. So this is actually how we started looking at sysmon. I wanted command line history as one of the things of my requirements, and sysmon provides that at a kernel level, which is huge. And actually a lot of our detections revolve around command line history. So what exactly do we really have here? We have visibility and power on the cheap. We really didn't have to reinvent the wheel. We just had to, like Sean said this morning, these are built into Windows. Half of Carbon Black or Falcon Host is already built in Windows. It's already there. You just got to kind of figure out a way to use it for what you want to do. So this was, visibility and power on the cheap is kind of like a, Barrett 50 cal. Lots of damage. You got a lot of range, a lot of visibility, and it's not super expensive. WMI provides a way for you to query the system. What's that? I know, I gave this to my buddy last night, and he said the same thing. He's like, you got visibility and power, but that gun's not cheap. I was like, yeah. But so WMI provides us a way to basically query the system for anything we want. If we're looking for anything in particular, I can pretty much, you give me enough time and I can find a way to create a WMI query to give me back that information that I'm looking for. And then we also have a kernel level driver with complicated preconditionals using regular expressions and conditionals to see 7 or 6 out of the 8 requirements for what we wanted to do in the first place. And it's missing something. I'm not sure if you guys kind of figured it out, but all of these things kind of live on their own. Each of these things is like a way to detect one indicator of compromise, but to develop a true signature suite of tools, we have to be able to correlate these events. I want to be able to say, hey, if something reaches out to this IP address and this process is started within 30 seconds of that time, and this file is also present, then I want an alert. I don't want an alert on each one of those things. I want to be able to create a conditional that says, if this, and this, and this, and also within this time frame. That's really where the power comes from, so that my signature can actually be high fidelity, and I don't have to, wade through 10,000 false positives. And that's really where the next person speaking comes in, Chris Boettcher, is we decided that we had all these ways of getting this information. We needed a way to correlate them all together locally and also through time. And so with that, I'm going to pass it off to Chris, who did a really great job developing a tool that he calls BAGELS. So with that, I'll pass it off to Chris.
on? Are we good? Can you hear me? Mic check. All right. All right. So we're back live. Why do we go with our own custom solution and not something off the shelf? Off-the-shelf products rarely allow you to use custom intelligence. So we have all these sources for intelligence that we can bring in, we can modify or use, and we go with something off the shelf. It's going to be 30 days, 60 days, 90 days before any of that intelligence gets used in production. And as they mentioned before, off-the-shelf products usually hook the kernel, and we did not want to do that because we don't want to blue screen anything. So the key features of BAGELS, it actively monitors endpoint machines for behaviors of interest. So this is a persistent agent that runs on the machine. And it allows for custom intelligence. And the core components of it, there are 3 different pieces to this thing. There's an event monitor, a behavior scanner, and an alert handler or dashboard. So let me hop here forward. Let's skip that one for time. So the event monitor is the first piece of this thing. And what the event monitor does is it goes and looks at the Windows event logs, and it looks at the WMI queries. It creates event subscriptions and collects that data from the system. So you tell the event monitor the kinds of things you want to look for. I want to look for, like Andrew said, I want to look for process creates. I want to look for processes being terminated, shared drive creations, USB insertions, all that stuff you can get out of WMI. Matching events get sent to the behavior scanner, which is the next component of this. But things that happen in the event monitor are not typically malicious. So these are things that happen all the time. Processes are created all the time. People plug in, disconnect USBs all the time. All that stuff is going on all the time. So the events themselves are not malicious. The next slide here, I've got an example of the event rules. It's kind of hard to see, just like yours was, Mike. I'll just go through real quick. So what we do here with the events is we kind of say, what do we want to look at? We want to look at, with a query, we're going to look at WMI and say, give me all the processes that are created, basically. The event subscription is handled by WMI. We're not constantly hitting it for anything. The application will just sit and listen, and an event will hit, and it'll come back, and it'll say, this process was created, or this USB stick was inserted. The attributes section, we can, if you go on MSDN, you can look at any of the different things you can query from WMI, and you can see all the attributes that can come back. We don't need to get everything because there's a lot of information that comes back. So you can limit the things that come back from your SQL query or your WMI query. And that's what the attributes section does. And like Andrew mentioned before, we can do related queries based on the first query. So if the first query is a process is launched and we want to know what the parent process was, we can take the parent process ID from the first query, do a second query, and come back with all the information about what launched it, which is useful information looking for stuff that, like an Acrobat Reader is launching some weird stuff, which is common, or, Word or other things like that. So, the behavior scanner is the second piece of this thing, and so every time an event fires, it sends that event to the behavior scanner. The behavior scanner is the thing that actually does the magic here. It looks for the bad stuff. So a process gets created, it sends to the behavior scanner, and the behavior scanner now has rules, separate rules from the event rules, that look at these incoming events, and they try to match or correlate them to other events. So it's a state machine that kind of looks at everything that's happening and says, is something bad going on here? Something like a USB stick is inserted, and then within 30 seconds a network share is created, or some other malicious process is launched, or something like you see run DLL32 execute a DLL out of a temp folder, which is something you don't normally see from non-malicious stuff, which will apply to a lot of different malwares, not specific malwares like a static indicator might. You might look for a specific thing in that malware. We're looking at more for the behaviors, the things the malware is doing that's bad. So again, the behaviors are collections of specific events, and not just like it could be a single specific event, but that's more like a static indicator anyway. So the real magic here is that we can take things from all the different sources, Sysmon, Windows event logs, WMI, and we can correlate all those actions happening to look for malicious activity. And the way we do that, or with the behavior profiles, which get a little more complicated, but the gist of the behavior profile is that you put in groups of behaviors that happen, and each group can contain any number of behaviors. Each behavior looks for a certain event type, and the top one you'll see is process create. The second one's actually all three of these are process create. So this is a real basic one that just looks at any process that is created. It looks for something that CMD executes stop on the Windows Update agent, which is something you're not going to normally see in a in your client production environment regularly. So something bad's probably trying to stop that service. There are other ways through Sysmon and through WMI that you can also watch all the different services that are started and stopped, and you can build these out so that they don't just look for one service stopping, but maybe this service gets stopped and another bad thing happens or another process is executed or things like that. At the very bottom there, you'll see a group operator in the within seconds, and that's kind of some of the cooler parts of what we're talking about here too. The group operator applies to the entire group of behaviors that you have there, and you can nest those as deep as you want. You can have different groups, within groups and things. But the group operator in the within seconds allow you to either say one of these things has to happen with an or all of these have to happen, or none of these have to happen. And the within seconds says, these things can happen over 10 or 15 seconds because this thing has to execute first, and then the user might have to open and click something, and then another thing has to happen. So we can, slow things down and look over a longer period of time. If you put the within seconds to 0, you're looking at all of these things happening in one event, like this one is, which is, again, more basic. And finally, we have an alert handler dashboard. This is really boring. I mean, the last piece is once the behavior scanner actually finds something bad that happened, it kicks that off to your cloud-based alert handler dashboard. You can see here I've got that's an example JSON output from a client machine where it actually saw the bad behavior happening. And it lives on there, and analysts can look at that kind of stuff. But I mean, that's BAGELS.
Yeah, cool. You guys got any questions about the project? Tony, what's up, man?
So you had 30 seconds as a time span situation that you mentioned a couple times.
Mm-hmm.
Like, do you find things that before that or after that time period, like pretty often?
30 seconds is pretty long, really. A lot of the stuff you're really going to look in more like the 1 to 10 seconds range, and that does happen a lot. Where like something will happen where Word will open, and it'll take Word a few seconds to fire up those macros, and the macros go do something, and then you've got bad stuff going on. So, 30 seconds is probably long for a lot of things, but it can do anything you want. So it can go minutes or.
And one of the things that we kind of found out is that your source types, like Chris kind of alluded to, there's more than one way to skin a cat a lot of times. So, for example, if you're looking at WMI queries that are looking for process creates. A lot of the really ephemeral processes don't get enough information for you to actually query them quick enough. But Sysmon does. So, and that's just a case of knowing what tools are available for you. And so the cool thing about this tool is that the events that Chris had talked about can come from any of those places that kind of Andrew had mentioned. It can come from Sysmon, they can come from Windows event logs, and they can come from WMI events. That's 3 right now, those 3 places. Those 3 places are a wealth of knowledge. So if you can't get it through WMI, Windows Sysmon, or Windows Events, then you're going to need to write a totally different plugin. One of the things that I didn't mention at the beginning that I think probably does require a little bit of clarification is that these 2 things that we talked about, Hashbrowns and BAGELS, are actually 2 plugins of a larger project. There's a larger project that we're currently working on within our group. We're calling it UHOP. It's the Unified Host Operations Platform. And essentially, that's our way of creating a lightweight agent. And the idea is that most organizations have way too many agents living on their machines, and there's a huge push to get agents off the machines. And our ask is we just want one. We want one lightweight one that basically just sits there, and its entire purpose in life is just to securely communicate and then execute plugins when needed. And in this scenario that we've talked about, the 2 things that we talked about, Hashbrowns and BAGELS, are both plugins to that ecosystem. And so it allows a single point of presence on the machine to do multiple things. And so if we wanted to create down the road, we wanted to create Andrew's memory analyzer because he gets sad enough that he wants to find reflected DLLs in memory or something like that. We can do that. We just have to create another plugin for it. We're definitely interested in some of the open source projects out there like Lima Charlie and some of those things. But right now it is a separate project that these things are plugging into.
Yes, ma'am.
In all your cases where you're querying data, how do you know that the data has been stored or not modified in a bad way before you even get to it?
Well, that's kind of one of the things about an endpoint and doing things on the endpoint is if the endpoint's comped, you really can't trust anything you get off the endpoint. But in our case, we've got about as close as we can get. We're using Windows query language to get information directly from a Windows service. So, I mean, I think we're doing
That's
the
a
best we
great
can.
question. We've talked about it.
Yeah.
And it's a hard problem. That's a very hard problem. So some of the other things that we talked about is one, depending on your environment, if you got a connection to the internet and you can get these alerts out there quicker, the whole idea is that you can offload these things before they can potentially be modified. So that way, maybe they do get modified, but you can go back and since you have a source of truth, like a one-way diode almost of how the alerts are flowing, you know that on the server, what had happened and what alerts you got, so you can kind of deconstruct that way. Another way that you can do it is you can get defensive in your programming scheme. So this is a conversation that me and Chris had, totally theoretical at this point, about all the different ways that we can remain persistent, and essentially we decided to create malware and create a rootkit to protect ourselves. And we're actually going to put that in as a separate module, maybe in some future land where we have more time. But no, it's an interesting problem, it really is.
Yeah.
I understand about pushing it out, on an external source, but how do you know that there's not something keeping it from being even out?
Yeah, I don't think that you ever know that for sure.
I was going to say, it would
So-
just stop checking in.
So the hope is that we get good enough with the behavior profiles.
Catch them before they have
Or
chance
the
to do that.
statics, yeah. So that we catch them as they're doing it, so we get a chance to beacon out before they can stop it. Stop us looking at them. But
And a good example of that is, and I didn't mention this, is that on the list of sysmon event types, 4 isn't listed on there because 4 is a special sysmon event type for if someone turns sysmon off. So there are some ways where we can detect if someone's at least messing with our program before they ever actually fully shut it off.
It is definitely a cat and mouse game, and it's one that's very difficult.
Yeah.
We're actually going to use the blockchain to
No, you're not.
cryptographically verify every single transaction that occurs
you heard it here
in
first.
runtime.
What's up, Nate?
GE said that's what we're doing, actually.
Yeah, blockchain.
Look for it in the next marketing.
Could something like BAGELS be used to, say, monitor certain commonly attacked file types that are used in like ransomware to immediately detect that some files are being tampered with in a way they shouldn't be, and then go off and maybe
Yeah, so I can think of a rule right now. So just look for open handles. Find query what open handles. If a process has has like 20 different doc files open at once, that's probably not legit. And that's a rule right there that you can look for.
So then what would you do with the other files that would you just kill that?
So that's another great question that goes back to one of our design principles. In our company, we don't do that. We don't block things. So that in of itself would have to be another plugin to our UHOP system. So BAGELS right now is totally passive. It only alerts, and that's by design. One of the big reasons why we do that is because we work in like OT environments where we're dealing with shop floor type of situations, ICS, SCADA, that sort of thing. And that was one of our design requirements that we had, is that we were not going to be a preventive system. We were going to be a defensive system. But you could easily modify or take the same concepts and do exactly what you said. You could create a HIPS type of solution where you do start to kill that process. Because if you see a process that has 30 doc files and open handles, there's very unlikely, unless there's certain ones that maybe you can exclude with their signing certs or something, put them on a whitelist using.
Even if it does happen, it would be a low false positive.
Yeah, and then you could go ahead and just kill that process and fire an alert. But we don't do that, but you could. That's the answer, I guess.
How are you doing it inside of email?
I'm sorry, what's that?
You like your indicator, your threat indicators, you say you did through email?
Oh, she's talking about your Yara scanning. You mentioned email.
Yeah, so we have a whole program called Fish Finder that essentially anytime that we get an email, we have network taps that just scrape them off, and then they run through a sandbox. But part of that sandboxing process is they also scan through all the YAR signatures. I did not work on that project, but I know that there are people who helped organize this that did.
Yeah, Yeah, and so
We're not
so,
naming
yeah,
any names.
That's a completely different project that actually correlates with Outlook. But at the same time, any attachment that you have or email that touches your endpoint is going to get written to disk, and then our whole system is going to kick in. Anytime it gets written to disk, it'll be scanned with our tool that will pick up on that.
Does it get written if it's inside the PSD?
No, you're right. Not unless you actually save it.
Once they extract it,
Yeah, not unless you save it to your end disk.
right? Not so much when it's inside.
Nah. As long as you're not interacting with it, I guess.
Speaking of that, going back to Hashbrowns, I think you alluded to the answer of this one. But so you run a full system scan, and then from there, you only go back and rescan files that change along the way.
Yes.
Correct. What do you do when there's a change to your IOCs? Or what's
Yeah.
there? Do you run another full system scan?
No. So there are actually two different types of scans that happen. There are scans that happen with the full list of IOCs. So let's say you have 400 different YAR rules that you're trying to scan for. You get a brand new file that's never been seen anywhere. You're going to scan those. All 400 rules are going to get scanned on that file. Let's say you add a new IOC. Now you have 401 rules. Now you're going to create a new scan that just has one rule. And what you're going to do is you're going to distribute that one rule across all the systems in your entire environment so that all the hashes get scanned. So if there's like overlap between different machines, those maybe, let's say 2 machines share 100,000 files, 50,000 of those will be scanned on one machine and 50,000 of those will be scanned on another. So that way it's not being scanned, duplicated anywhere in your environment. And the other thing that I wanted to mention that I didn't really do a good job of explaining is that after you do that full system inventory, when you do that full system inventory, all you're doing is you're checking file paths and hashes. You're reporting that back up to the controller, and then likely, because most operating systems share a lot of the same files, likely you're only going to need to actually scan, maybe 10% of those files. And then you can go and distribute the rules to just those 10% of those files. You don't have to scan the other 90%. And the controller will know that because it has a list of all the other hashes everywhere else in the environment and what rule that they've been scanned to. So then it can send back and say, hey, scan only this 10% and scan it with this rule set. Did I answer your question? Cool.
Do you whitelist in like the known operating system things to just say don't ever go back and check those?
That's definitely something that we're talking about doing.
We've been searching for different, big databases of safe files and hashes and things, and looking at ways to incorporate that.
Is a project that we're looking into integrating, and that's just kind of one of those things on our to-do list.
Sure.
So it seems that Bagel is targeted client side. Do you guys have any plans to do server side?
There's really nothing stopping us from running it on servers as it is right now.
Yeah,
and
we've
in fact,
actually are running
I was
in a
gonna
pilot
say,
with some servers right now.
Yeah,
Yeah, it's
our
running.
beta test is on servers right now as we speak.
Yeah, I mean, we're running it on servers. I mean, when we say endpoint or host, we're talking any endpoint or host to include servers. But I mean, we mean not network because we're not really like looking at things on the wire.
Right.
And one of the reasons why we really wanted to focus on the host is just because networks are changing. The perimeter's changing. In most environments, I mean, everybody brings their own devices, to work. Their laptops can connect to multiple different networks. You probably have a proxy that you go through, but other than that, the whole idea of a corporate network is becoming a lot more fluid. So that's why we're trying to do a little bit more focus on the host. Not saying that network analysis is not still very, very valid, but I think that there's been a lot more emphasis on that in the past, and that's why this project is focusing on endpoints to include servers.
Anybody have any questions? All right, well, thanks for letting us speak to y'all.
Thanks, guys.